Welcome. Types of loads, part 3. As I told you, part 3 is for uniformly varying load represented by a triangle. I told earlier, 3 cases are there. One, see, by a right angle triangle. See, by a right angle triangle, this way or this way. This already over in previous case number 1. Second one, what you are doing today? UVL represented by an isosceles triangle. See here, this one. Last case, next class will be UVL represented by a triangle in general, randomly, this way. Either that can be more or this can be more. See, anything. This is your next part. So now you are considering uniformly varying load represented by an isosceles triangle. It is a very simple one. Class will not last more than 10 minutes. See now. See, first, case 2, UVL represented by an isosceles triangle. Now, class. Something I will tell here in the class. This is the case of uniformly varying load. I am dictating, you should write varying load where intensity is 0 at the, see, L0 is the loaded length. At the ends of the loaded length, which linearly increases to maximum of W per unit length, exactly at the center of the loaded length. That all you have to write here, if you want to thoroughly understand. Or at the center of loaded length, maximum W, which linearly reduces to 0 at the ends of the loaded length. That statement you write. Now, what we want. Last time I told 1, 2, 3, 4. You should write 1. Magnitude of the total load for loaded length considered. Second one. Then hand should move like this. Second. Direction. Very simple. Direct vertically down here. 3. Line of action of that total load. 4. Moment of that total load about 2 extreme ends of the loaded length and also 2 point outside. Inside point I will take later. Okay, these are the 4 you require. Okay, now these all you write. If you want to systematically understand, write. Okay, now start. See, L0, loaded length considered. You write here. Consider an uniformly varying load loaded between the points A and B. Loaded length is L0, where intensity at the ends A and B is 0, and this point I can call C. I won't call C. I won't call anything. I will leave it. I won't call this name, point. And exactly at center, it increases, it becomes maximum of W per unit length. Consider one point left side of A, say C at x1. 1 point to right side of B, say x2. Now, one by one. First, you require magnitude of total load. Start. See, as I told you, magnitude of the total load means hand should move this way. You should mark where it is acting. It will pass through centroid of the loaded diagram. Since it is this length is equal to this length, see, for the entire loaded length, see, for the entire loaded length, centroid will be here, exactly center. So, this is for, see, full, this one, this full load, magnitude of total load for loaded length considered equal to L0. Equal to, answer. I told repeatedly from beginning, uniformly varying load, whether you represent by triangle or trapezium, in triangle, right angle triangle, isosceles triangle or triangle in general, or any type of load, even parabolic load, trigonometric function load, whatever it is there, total load is given by area of load diagram, full area equal to half into full L naught. L naught into W. One bracket required. 1 minute. Check the camera. I think no problem. Yes, no problem. Something happened there. See. When I moved there, it shifted. Camera got shifted. Okay, now okay, I think. Now okay. Sometimes what happens is, little touch means camera will move. Okay, okay. It's minor things. So this is over, magnitude. Direction down. So magnitude, I told first one, magnitude over, direction over. Next right here. Somewhere here, right here. Here. Line of action of that total load. That total load means same thing. Total load for loaded length considered. That total load will pass through. You should write, if you want, write here. Line of action of the total load, that is for loaded length of L naught, will pass through centroid of diagram representing the load. Dia means diagram, not diameter. Representing the load. That is at, see here, centroid is exactly midpoint. From here, L naught by 2. From here also, L naught by 2. Overlapping, okay, no problem. What to do? L naught by 2. That is at L naught by 2 from ends of loaded length from either A or B. This statement, this will complete magnitude, direction and line of action. Now we want moment. For that, I will start moment now. Okay. When you want to moment, you draw one more sketch, not this sketch, because at that time, these all will not come. None of this will come. See, I told you clearly earlier. Now your x1, x2 will come. See, this is L naught. L naught by 2, L naught by 2. Oh, actually, sorry. You don't have to write L naught by 2 because it's already there. Okay. That will be there. No problem. I forgot it. Okay, now. Actually, when you mark the centroid here, understood, it is L naught by 2. Okay, now see correctly what you want. Now we want moment of total load for entire loaded length of L naught about okay, start A. About A. Now, do one thing, as I did last time, 4 times required. What you have to do is, those who want, write. I am not writing now. It is already over 100 times. When you want to moment about any point, total load, hand should move this way into perpendicular distance from that point to line of action of the load. So, light line here without disturbing. See, actually should not disturb it. This is the total load. You can write here total load, magnitude. Now, from here to here, you can see L naught by 2 already over. Therefore, if I want moment about A, see, total load half into L naught into W is the total load. This is the total load, direction down, multiplied by from here to center of loaded length, centroid of loaded length is L naught by 2, moment is clockwise, over, right. Now, below this write, you should write every time. Don't write what I am doing. Moment of the loaded length, entire this one, about B. B equal to, once again, total load remains same, into once again, L naught by 2, about B, it will be anti-clockwise, over. Now do one thing, write once again below, moment about C. total load, same, half into L naught W into X1, what is this disturbance? Some police siren. X1 plus L naught by 2. Clockwise, over. Lastly, right, moment about D. Below you have tried. You have tried 4 times equal to moment about D. Same load into X2 plus L naught by 2, this time anti-clockwise. Very, very simple, over. Now, I will go to numerical example. Numerical example, then this class will be over. Very short class. Right, now numerical example. First, I dictate in the class. What all I dictate, you have to write. Consider an example of uniformly varying load represented by an isosceles triangle. Let the loaded length be 12 meter. Y means my choice. Then, isosceles triangle means either side equal. So, intensity is 0 at the ends of the loaded length, and when you come to center of loaded length, that is, if it is 12, 12 by 2 equal to 6 meter, 12 by 2 equal to 6 meter. When you reach there, from either side, linearly increases and reaches maximum of 30 kilonewton per meter. Over. Now, what we want? Same. 1. Magnitude. 2. Direction. 3. Line of action location. Moment about points. We want moment about A and B, and one more point to left of A by some random distance, 2 meter. Okay. One more point to right of B, say by 1.6 meter. Random. Okay, over. Start. First, magnitude of the total load. See here. Will pass through centroid. I told here. Where is the red color? Here. To centroid. Centroid for entire loaded length. See, this is the magnitude of total load for entire loaded length of, not L naught now, 12 meter, equal to the total load equal to area of the triangle half into 12 into 30. That much kilonewton direction down. How much answer? You write. If you want, you write. I am not interested. Okay. Total load over. Now, next write somewhere here. And don't see here. See, I am writing here. Actually write, don't see this side. You write here only, write. And see, and line of action of that total load, or you can write the total load for loaded length of 12 meter will pass through centroid of loaded length considered of 12 meter. That is at, see here, this is 12 means at 12 by 2 equal to 6 meter from either A or B. From A or B. Both are okay. First you make this note. Once this is over, now we want moment. Draw one more diagram. Remove all this. Not remove all this actually. Once again, you have tried everything. Okay, start. Now, see, this way. Only original sketch. If you don't follow what I tell and do your own way, you will lose. Okay, see. Now, we want moment about A, moment about B. You should write the ends of the two loaded length, one outside point at 2 meter here and 1.6 here. So, if you want to moment, how many times I have to tell? Total load you require. So, it will be somewhere here. See, light line without disturbing. straight line. This is the total load. For the entire loaded length and distance from here to here is already there, 6 meter, 6 meter. Okay, start now. Moment of the total load, entire loaded length of 12 meter. Red color 12, okay, not black 12. Entire load length of 12 meter, not L0 now, equal to total load half into 12 into 30 is the total load. This will be total load in kilonewton, direction down. See, total load into from A 12 by 2. Don't write 6 meter. 12 by 2, that much kilonewton meter clockwise. About A over. Next write. Oh, sorry. About A. I forgot. I rubbed it. About A. Okay. Over. Now write. Now once again, moment about B. Same load, same distance, but anti-clockwise. Write once again if you want. Once again you are right. Next. Moment about C. See, finger here now. Total load is already there. Half into 12 into 30 into 2 meter plus this is 12 meter means half of 12, 12 by 2. Clockwise. Okay. Lastly, below right, moment about D. Once again, see D. Same load into 1.6 plus 12 by 2 kilonewton meter anti-clockwise. Yes, this will complete. Intermediate point I will take up later. Remember, at that time I will take UDL, UVL by right angle triangle, UVL by isosceles triangle, and also general triangle. That class may run for more than 2 hours because there lot of importance are there. When you want somewhere in between, etc., problem comes. See here, if you want about this point, this side triangle, that side triangle and trapezium. If you want about this point, both sides triangle. But if you want about this point, this side triangle and trapezium and triangle. But if you want anywhere outside this point, only triangle. If you want anywhere outside this point, only triangle. That all I will explain. So, this class part 3, case 2, UVL represented by an isosceles triangle is over now. Next class will be same uniformly varying load represented by a triangle. Case 3, UVL represented by triangle in general. Means not right angle triangle, nor isosceles. Random means what? Different distances here. Little important. Or concept will be there. That will take around 1 hour, I think, most probably. Because why? 2 cases I have to solve. One, when left side is smaller, right side bigger. When next right side smaller, left side bigger. 2 bookworks and 2 numericals. So I think around 1 hour. Even last class also, see, it took nearly 50 minutes. Today, because of very simple one, it is over. Actually, it will take in 5 minutes only. But after dictating or explaining everything, it took around 15 minutes, I think. Okay, thank you. See you in the next class.